welcome everyone. So I'm Curtis Stewart. I'm a CPHC, lead green associate, and a CSI construction documents technologist. In today's presentation, it's going to be led by Tom Boeman. Tom's a licensed architect. He's a principal at Boeman Design. He's a certified passive house consultant, CPHC, and lead AP. He also sits on the board of the local chapter of Phius Alliance. I think we can just pass it to Tom and he'll begin the presentation.
Thank you, Curtis, and welcome everyone to Phius 101. First, we're going to talk about who is Phius. So Phius is an acronym for the Passive House Institute US. It's one of several organizations committed to the passive house general approach and building standards, one of several around the country and the world. And what does Phius do? They certify design professionals, they certify builders, they certify products, they train people in the modeling of passive house buildings. They publish the Passive House Standard, which we're going to talk today about the Passive House Core and the Passive House Zero standards. And they also do a lot of fundamental research around building sciences related to high performance buildings. And what is passive house? Passive house is three things. It's used colloquially as an approach to the design of high energy performance buildings. It's a building that is designed using a passive house approach or certified to a passive house standard. And it's also the name of a standard for building energy performance developed by one of the several passive house organizations, which you saw on one of the previous slides. In our case, we'll be talking about the Phius Core standard and the Phius Zero standards that are developed by Phius. And a passive building is one that reflects a rigorous understanding of building science and climate data and aggressively applies them to achieve high energy efficiency and superior indoor air quality. And some of the collateral extra benefits of that include a quiet, comfortable indoor environment and resiliency during power outages. And the word passive figures prominently in the passive house name. And a passive approach starts with energy conservation and prioritizes the design of the enduring physical components of the building, such as orientation and siding, building geometry and massing, walls, roofs, windows, and the grade condition. So all those kind of building components that you expect to outlive us. It uses active measures, it uses active technologies, but the fundamentals are founded in getting the basics correct. A passive building doesn't have to be a house. Passive buildings includes residential projects, multifamily projects, educational projects, and also institutional and commercial projects. The standard's been around for a while. Since the mid-1970s, it kind of grew out of movements there in Urbana, Illinois, where they were first starting to explore some very reduced energy use buildings. It started out during the energy crisis here in the United States in the 70s, kind of got adapted in Germany and became the passive house standard, where it really became a rigorous standard, and then found its way back to the United States, where it's incarnate here for the most part as the Phius standard that we'll be talking about today. In terms of where it fits in the world of other standards out there, it's really the creme de la creme of the US DOE high performance staircase. So if you look at on the far left, kind of minimal standards like the Energy Conservation Code is meeting some basic criteria. The Phius Core and Phius Plus standards are on the extreme right, adopting a lot of the strategies and a lot of the actual specific criteria of some of these other standards. For example, in EPA Indoor Air Plus is adopted across the Phius Core and Phius Zero standards. We don't talk about this a lot specifically, but the Phius Core is a kind of basic conversation, low energy performance building. Phius Zero is a net zero version of the standard. The standard has two basic strategic components to it. It's based on modeled performance, so there's an energy model associated with each of the projects, and on-site assurance and testing and inspection. So that uses recognized systems, Department of Energy, EPA, IAP, and ResNet. Third-party inspections process that involves multiple site visits, blower door tests, and system commissioning for the most part. The standard includes a number of just specific targets you have to meet to pass the standard and get certified. The first batch of targets are the space conditioning targets. These are based on COPT optimized analysis, and they vary based on the climate, occupancy density, and envelope and floor area ratio. There's an air tightness target, which is just simple number you have to meet, 0.06 cubic feet of air per square foot of envelope area at 50 Pascal. On-site quality assurance and testing and inspection. Again, we mentioned that. And then there's a net source energy target, which also has to be met by every building. So those targets are specific to the project. So for example, the space conditioning targets are based on the climate, which is determined by where your property is, and the building size, the envelope area, the floor area, the number of dwelling units in the case of a residence, and total bedrooms in the case of a residence. And this is actually the form that you find online when you register your project. You fill this top part out, and it spits out your space conditioning criteria. So there's 4 of them: annual heating demand, annual cooling demand. Those are basically your total energy use over a course of a year. Peak heating load and peak cooling load, which are the peak load you might encounter in winter for the heating load, and in the summer for the cooling load. The climate data, again, it's specific to your location. So they have all these sites mapped out across the country. When you register a project, you pick the location closest to you, typically in this case in Chicago O'Hare or Midway Airport, one of the airports. And the last of the targets is the certification level. Based on the certification level, which is your source energy criteria. For Phius Core, it's kind of a per person per year rating. And then for Phius Zero, where you're going for net zero, that target is 0. And the source energy nomenclature, source energy simply means your site energy is what actual energy is consumed on site. It's reflected in your energy bills. The source energy is a site energy, but includes the losses associated with generating and delivering fuel. So there's a source energy factor associated with the fuel type. For electricity, it's something like 1.75. For gas, it's 1.1. So depending on your fuel source, it's how you convert from the site energy use to the source energy use. And so those targets vary. In Phius Core, it's a kilowatt, it's a per person basis. And for commercial, it's a per square foot basis, how much energy, what your source energy target is for your project. And those, again, were given in the online form when you fill out your project. And I'm going to turn it back over to Curtis to kind of introduce us to some of the passive building principles and dynamics.
Sure, yeah. So the principles to help meet those program targets and requirements we just were looking at, and which you'll find pretty much in every Phius certified building. We're going to review primarily the top half of those principles listed here, such as air barrier layer, thermal control layer, but we're not really going to dive too deep into those circles at the bottom, such as moisture management, details of HVAC systems, or the high growth thermal analysis, which predicts dew point, long-term durability, and heat flow of building assemblies. But we say start with a compact form because McMansion or like a Queen Anne, it won't work, but it really does tend to do very well with multifamily buildings, the Phius standard. The strategy is to first reduce the heating and cooling loads and demands. Continuous insulation around the entirety of the building, continuous and durable airtight construction, manage solar gains through orientation of the building, sometimes strategic placement of windows, shading, as well as very efficient balanced ventilation, which also brings filtered fresh air into the space. So with the reduced heating and cooling loads, this allows for minimal heating and cooling systems. So you can often use heat pump systems and then further reduce energy usage with very efficient lighting and hot water systems. So the additional energy burden can be offset by renewables. And we feel this order of operations is really the most efficient way to Phius source zero and to net zero energy use. So diving into a little bit more detail, the continuous insulation, it reduces energy losses through the building envelope. So you'll notice the continuous insulation in that image. It's throughout, even under the concrete slab, around the concrete slab. For the insulation materials, you'll probably use a few different types. Take into consideration R value per inch, the embodied energy, global warming potential of the material, its permeability, even the density. But you're going to use a lot of it in this climate zone. And high performance windows, often triple pane with very highly insulated frames. And those specialized windows on that last slide, they have a thermal break, so that heat doesn't really conduct through the window frame. And you can see that little image there of therm was used, a program to measure that there's a thermal break in that window frame. So there are points of weakness in the continuity of insulation. It's called a thermal bridge. So we have an example of a thermal break there, and then an example of the thermal bridge on, I believe, your left side. So areas you'll commonly see thermal bridging. Here you have a balcony, roof wall connections at corners, the wall to foundation connection. Also, thermal bridging can be points as well. So, penetration in the building envelope. A very small thermal bridge, it really can have a significant impact on performance. So that is a reason why we try and minimize thermal bridging, but it can also present a significant risk of mold or condensation due to the lower surface, inside surface temperatures, which in turn will lead to building deterioration. So airtight construction and airtight design, it limits airflow through the conditioned and unconditioned space or outdoors. The air barrier has to be continuous. That's why you see the red line all around that image there. It has to be durable for the life of the building, because air infiltration causes heat loss, contributes to building failure by pushing moisture somewhere into that assembly. Airtightness details, they just need very careful planning, need consistent execution throughout the stages. So it's verified at stages in the construction process. So the Phius Radar will do blower door tests, which really help identify air gaps, any penetrations that need to be sealed, and then measure the overall leakage and CFM. And that's part of the quality control process. Then to manage solar gains, consider the orientation of the building when possible, but window placement, selection of window type and type of glazing, the amount of windows really influence design in Passive House. You'll find more windows at southern exposure, but it's best to have overhangs or permanent shading to limit the overheating in the summer. But that area is a great place for windows. You don't want too many windows in the wrong area, because window technology just doesn't compare to the insulating value of like a wall assembly. So we have to be very strategic in window placement. And to dive into mechanicals, I'm going to pass back to Tom.
So the next kind of on our pathway approach is balanced ventilation. This is the first time you're going to start to see some appliances and things that you're not used to seeing in your house. So what's pictured here is something called a heat recovery ventilator or energy recovery ventilator. It's not something I have in my house, but it's one of the kind of things you'll see as a common kind of feature of a passive house. We're going to look at what the difference is between kind of random ventilation and controlled ventilation. So if your house is anything like mine, it looks more like the one on the left. This is random ventilation. It's winter, our windows are closed, yet we still need to breathe, and yet we still get fresh air in a house. Mostly because it leaks out with these orange lines through the roof. The warm air rises, leaks out through the roof, and that draws in cool air, outside air, through the building envelope, through your dryer vent, through your range hood, and all these places you really don't want fresh air circulating into your environment. Versus a controlled ventilation approach, which Passive House takes, where you actually try to manage where that ventilation occurs. Curtis described airtight construction, and with airtight construction, you need to make accommodations for ventilation, and you want to do it in a controlled and managed way so that you can exhaust air from your building from places like bathrooms and kitchens where you have interior pollutants and supply air into the living spaces and the sleeping areas. So controlled ventilation improves your indoor air quality. It brings in fresh air at a consistent rate, at a high rate, and it brings it into the bedrooms and living spaces. It exhausts the stale air from bathrooms, kitchens, and laundry rooms. It can also filter that incoming air. You're not bringing it through your building envelope where it might be coming through fiberglass insulation or something. You can filter the area out because it's ducted, and it reduces the condensation and mold risks. You don't have air on its own going through the building envelope. You have less opportunities for moisture penetration at those points as well. And also importantly, it allows for something called energy recovery. So this is a energy recovery ventilator, which was in that first slide on this topic. And it's worth spending a moment on the details on how this actually works. So if you look at the right side, that's your interior where you have air that you've already spent the money and spent the energy to heat up to 68 degrees. And you need to exhaust some of that and bring some fresh air in. Well, if it's 32 degrees outside, your fresh air is going out at 68 and your cold air is coming in and replacing it at 32 degrees. So what an ERV does, or an energy recovery ventilator does, is it passes those two streams of air through something called a heat exchanger. And so that the heat gets transferred to the incoming airstream so that only comes into the house at 62 degrees versus the 32 degrees of the outside air. Heat exchangers are kind of a novelty to us, but they're actually a very old technology. They've been around as long as the Industrial Revolution. And it's really not much more than a sheet of metal that separates the two air flows and allows them to conduct their heat naturally between one stream and the other. So it's a very important, very simple idea, been around forever, but not been applied to building ventilation until relatively recently. The next component is minimized efficient mechanical systems. And in passive house, since we're mostly thinking electric, we should be thinking heat pump, and that's what's illustrated here. This is a Mitsubishi mini split system or somebody else's mini split system, but it's basic heat pump system. The way to think about a heat pump is you want to compare it to what the alternative is. It's very easy actually to convert electricity into heat. You just run it through an electric resistor. So if you look at the left-hand side, you see electric resistance heat, where if you bring in 3,600 BTUs per hour of electrical energy in, you can convert that to heat at pretty much 100% efficiency and produce 3,600 BTUs of heat output. A heat pump does something much different. In a heat pump, that 3,600 BTUs per hour of electrical energy is used to drive refrigeration cycle. It drives a compressor, which compresses a refrigerant. The refrigerant gets hot, rejects its heat to the inside. It then runs through an expansion valve, gets very cold, sucks some additional heat from the outside, and then runs again and continuously cycles it. So it moves heat from the outdoors to the indoors. So with that same 3,600 BTUs of electrical energy coming in, it can deliver 3.5 or more times that into the space. So with only 3,600 BTUs, you're getting 1,600 BTUs of heat delivered into your space. So that's why heat pumps are kind of the means of choice to heat buildings in the passive house, but they're not the only one. Again, this is a technology that is relatively new for this application, but it's been around a long time. If you have a refrigerator or air conditioning, they're heat pumps. They just only pump in one direction. They pump heat out of the house or out of your refrigerator, but it's the same underlying technology. And again, once we get into the other systems, lighting and water, again, we're focused on efficient LED lighting fixtures, which everyone is kind of used to by now, Energy Star appliances, but also a lot of attention to how your domestic hot water systems work. They consume a lot of energy, and there are ones that use heat pump technology these days rather than the electric resistance like we talked about with the heat pump discussion.
So Q&A. So Tom, I've heard there's a point of diminishing return on adding a lot of insulation. So how far and how far should I go with passive measures? Like, do I just keep adding insulation? When do I stop?
So the Passive house standard is designed to kind of optimize that, because obviously you could always spend more on insulation, always spend more on passive measures to reduce your energy use, but at some point it's a diminishing return. This is a kind of illustration they use to illustrate their setting methodology. Basically, if you can see this diagonal line coming down, that's kind of your energy cost. With more efficiency, your utility bills go down, and you could bring your utility bills all the way down to zero with enough insulation and a few solar panels, right? You could bring that completely down. Unfortunately, the cost of all that extra insulation, the cost of that eventually starts to outpace your budget. So if you look at the far left, this is a normal measure. You hit there, you start doing some energy saving measures. Your total energy costs and mortgage costs might go down a little bit, but at some point, it's just going to get more and more expensive. So Phius shoots for a point about here where you're not necessarily the absolute cheapest in terms of performance, upfront costs versus operating costs, but leading edge a little bit, but better than you would be if you did nothing. So that's kind of how they optimize it. And that's built into how the targets are generated. So you don't have to engage the cost so much in your work as a designer of a passive house. It's kind of built into the way the targets are calculated. And it's tested on a wide variety of building types, everything from houses to large buildings.
So that was a screenshot of the BOP program from NREL, right? But apart from design requirements and energy modeling for Phius certification, what are the requirements are there just to ensure the quality of the project?
So Phius, in addition to those kind of targets that we looked at on the target page, Phius does require Energy Star appliances, and all your Phius projects will meet the EPA Indoor Air Plus requirements, including the design of combustion venting systems if you have combustion venting in the house, radon resistant construction, and low emitting building materials. So there are these other collateral requirements you have to meet just to assure your indoor air quality. And also, again, it's an on-site quality assurance program. So you have to, critical to the success of the project is providing assurance that the built product is what was actually planned. And again, it's built on the US recognized system third-party inspection process.
So when should I turn to renewables to offset source energy usage?
So Phius has two targets, the Phius Core, which targets that kind of sweet spot that we mentioned before, and then Phius Zero, which is targeting a total net zero operational energy. Now, even in a Phius Core project, it may be that your energy use is a little high and you'll need some photovoltaics to hit the targets. That's allowed and that's sometimes required, in fact. But with the Phius Zero, you're almost guaranteed to need to put photovoltaic, well, you will, because that's the only other source to get your energy. So if the Phius Core is there, if a baseline building is here, Phius Core is meeting the Phius Basic standard with the addition of renewable energies in the form of either your own on-site production or a purchasing agreement for renewable energy, you can get to Phius Zero. And that just means that all of your on-site used energy is offset on an annual basis by renewables. So it doesn't mean you're necessarily powering your house with the photovoltaics on your own roof, but the total generation you do in the course of a year is equal to the total energy consumed in the course of a year. So getting to zero, we have this little animation. The foundation of that is quality, health, and durability. Next step is passive conservation measures, as we discussed. Then any active conservation strategies, this gets us to meeting the core standard. It really takes all of these to meet the Phius core standards. Then on top of that, on-site renewable energy. And our last peak would be off-site renewable energy. So those are all the kind of measures available to us in priority from the foundations to get to the Phius Zero standard of zero net energy use for the building. So again, first passive, then zero. Step one, conserve. Step two, offset with renewables. And next, we'll jump into what this certification process actually looks like. As you said, there's two basic parts to this: design certification, which is based on the modeling process, and final certification, which is based on the field verification. One of the most important parts of this, and the first thing you need to do, is build an effective team. That usually requires a Phius certified professional, Phius certified design consultant. They're required, you need to do this during the course of the design. It's not a standard where you can build a project and then go back and get it certified. It really is a design standard. So the Phius consultant will help you through designing the project. Then the certified builder, they're not required, but they're very helpful, because often the weak link in executing a certified project is the builder, because a lot of them don't have experience with some of the building issues we've addressed, particularly things related to air barriers, and sometimes things like ERVs and heat pump systems. It very much helps to have a Phius certified builder. And the final team member is the Phius certified rater or verifier, and they're the ones that do the on-site verification of the project. The project proceeds in various steps. There's actually a phase 0, which is kind of optional, but it's actually, I recommend it. As I've been the certified passive house consultant on a number of projects, I found it very useful to have Phius do a feasibility study. They basically do an initial model of it and just make sure the project's possible to get Phius certified, and what some general guidelines on how to get there would be. The next one is phase 1, which is really a lot of paperwork, filing the project, getting the invoice together, and getting a contract with Phius. And really the milestone in that is getting the project registered. The next phase is getting the design certified. That's when the certified passive house consultant is doing their modeling. They go through several reviews with Phius on the energy model. And Phius literally looks at every setting in the model and gives you feedback on it. And once that's done, they'll give you a pre-certification letter. Phase 3 is construction. And then this is the time in which the rater certifier will rate the project. They have a lot of paperwork to submit as well. There's a lot of documentation that needs to be completed. They make sure everything is designed, and they conduct the blower door test. Everything is executed as designed. There is now, as of late last year, there's another alternate approach for Phius Core. It's called the Phius Core Prescriptive path. And that path consists of a couple components. It's limited in scope, this kind of single family townhome type projects. There's airtightness requirements, compactness, solar protection, thermal enclosure, moisture risk mitigation, mechanical ventilation, mechanical systems, lighting appliances, and hot water. The difference between the prescriptive path and the one you saw before is that the one we saw before gave us general heating demand and load requirements, and we had to figure out how to design a building to hit those. That's what the CPHC and the design team do. And the prescriptive path, they're much more detailed. They just say, hit these targets for example, heat transmission, some recommended R values, effective R values for the roofs and walls and whole slabs. So you just have to meet these targets. You don't have to go through the process of modeling them. So it basically gives you a very rigorous game plan to get to the target. And there's much less design work associated with it, and no energy modeling required. So it's a much simpler process. There's still paperwork, there's still documentation you have to do, but it's prescriptive. It tells you how to do it. But our second to last kind of group of topics is just how the standard is doing. We're calling this Phius Growth. Currently, there's 950 submitted projects in North America. There's over 13,000 units and over 16 million square feet of, I believe that's certified space in the Phius certified program. Just to give you kind of a sense of how the market is going, it's still, it's still kind of early. There's not a huge percent of the total building out there or being certified, but there's an exponential growth in Phius's certified, projected certified, and pre-certified projects. So the growth has been exponential. Phius is very busy. They're certifying a lot of projects. So it's getting to be much more, people are getting much more familiar with it, and it's making much more of an impact into what's actually in the built environment. A lot of housing agencies, housing finance agencies are recognizing passive house buildings for low-income tax credits and other incentives. And this is just kind of get a sense that, there's a lot of states recognizing the Phius standard and offering incentives around it, including incorporation to stretch codes. and other quality assurance programs that might be required for financing and or permitting. Our last kind of category is resources. So Phius does have a lot of resources at their disposal. Some of these are really more specific to people in the trade. This first one is invaluable if you're a CPHC working on certifying a project, and that's your Passive House Standard Certification Guidebook. Very detailed, outlines exactly what needs to be done for every type of situation that you encounter in the design of a passive house. You know, I consult it when I need to figure out how to calculate the performance of a hot water system and work with the piping sizes and stuff like that. It's just a very detailed certification guidebook. Also has fee schedules and things like that. Professional training. They offer a number of programs: Phius Certified Consultant, Phius Certified Builder, the Phius Certified Rater, and Phius Certified Verifier. In our introductory slide, we noted a couple of the upcoming trainings that they have. These are very good for people, mostly going to be involved in the practitioner side, professionals. And also training in the WUFI software, which is the software that you have to use for modeling the projects. All the projects that are modeled using an application called WUFI Passive, and they offer a number of training packages for that: Single Family Pro, Multifamily Pro, and for beginners. They have a number of online resources for multifamily, separate URLs for multifamily.phius.org and commercial.phius.org. So the passive building design guide, a policy roadmap, passive building, and another passive building design guide for commercial projects. Again, these are not necessarily consumer oriented. They're more towards professionals, other practitioners interested in the standard. And that was our last slide.
Thanks so much, Tom. I'd like to thank everyone for joining us.